in D block, copper 2 plus, that is aqueous copper 2 plus ion, combines with iodide, that is aqueous ion of iodide. So what could be the result on the right hand side? We will discuss. Similarly, silver chloride reacts with the ammonia to give what? Let us discuss. Let me take up the first one. Copper 2 plus is an aqueous solution, combines with iodide to give dash and dash. So we have to fill up. You know very well, that is, you have to try to get the chance of combining. The copper can combine, this is cation, this is anion. So it can combine as copper iodide, and when you say copper iodide, it can either be copper 1 iodide or copper 2 iodide. But since it is an oxidation reaction, that is redox reaction, we have to give the other product, either oxidation product or reduction product. So focus on I minus. So I minus should become what? Some 0, then only minus 1 becomes a 0, means what? Whether it is an increase in oxidation number or decrease in oxidation number. I minus becomes I0, means increase in oxidation number or decrease in oxidation number. Increase in oxidation number, minus length is 0. So you must put definitely I2. So in that case it should be cuprous. So you can put cuprous means usually CuI, but this is a dimer ion, so you can put cuprous like this, Cu2I2. This is the way you have to mention. Okay. Now what about copper? This is having plus 2 oxidation state. So plus 2 becomes here plus 1, is it not? Audible follow? Why I have put a copper 1 iodide? Because it is already copper 2. Okay, so in that case it should be reduced to copper 1. Okay, so here it is copper. How to find out? You can work out like this. Cu2 I2. So Cu minus 1, I mean I minus 1, put x. So definitely that is 2x minus 2 is equal to 0. 2x is equal to 2, x is equal to plus 1. So you should have the oxidation state plus 1. Are you able to follow? So it means that is plus 2 becomes plus 1, that is reduction. So this has undergone reduction, is it not? So reduction is represented by H. And what about this? This has undergone oxidation. How? Minus becomes 0. Now we have to balance it properly. Okay. So just by looking at the reaction you can do it. Otherwise you can proceed. You can follow the redox reaction procedure. That is oxidation number technique for balancing the reaction. So here 2 electrons, I mean plus 2 becomes a plus 1, means how many electrons are added, because addition of electron. So addition of electron can be indicated like this. Okay, and here a drop of electron. How many electron? Only 1 electron. Minus becomes 0. So 1 electron is dropped, and here 1 electron is added, so that plus 2 becomes a plus 1. Is it clear? So you can exchange and nothing will happen. So you can simply write Cu2 plus plus I minus, is it not? So that gives Cu2 I2 plus I2. Okay. Now you can adopt the element ERP method, reactant product. Okay. So this is the way you have to balance the reaction. And the main metals cations are Cu, and what about this? Iodine, and here that's all. So Cu and I only. And in the reactant side, how many copper? 1 copper. Product side, 2 copper. and on the product reactant side iodine 1, and this is how much? 2 plus 2. You have to write like this, 2 plus 2. Okay, so in this case you can multiply this by 2, so you can put 2, so balanced, and here 2 plus 2 4, so you can multiply this by 4, so you can put 4. Now this is also balanced. So this is the procedure you have to do. You can at random you can do, but this will give you a clear picture of balancing the chemical reaction. Okay, now let us proceed with the next question. AgCl, silver chloride, it's a salt plus NH3, that is ammonia, aqueous ammonia, to give, actually this gives a soluble product. Okay, so and it gives AgNH3, it just like that it combines AgNH3 twice. This is diamine, not ammonium, diamine. Amine means not NH2, diamine, that is 2NH3. Okay, so Ag2NH3, that is, this is the ligand, and Cl. Now can you guess what could be or what kind of compound it can be? Complex compound. So how to name this compound? Diamine, double M. Diamine. Tell me. Silver.
Chloride.
No. This is a complex outer. Yeah. Diamine, chlorine, diamine, silver, chloride. Diamine, silver, chloride. Yeah, you can put the bracket also. Okay. If I put the bracket, definitely you will find it is a complex compound. That's why I put it. Okay, right. And you please check whether it is balanced. It's not balanced. Okay, so simply you have got 2 ion. You can put simply 2. That's all. Okay, so this is a very important compound. Let us proceed with the next question. Let us take this question. Why is chromium 2 plus, Cr2 plus reducing and Mn3 plus oxidizing? Both of them, though both have D4 configuration. So the point is both of them have D4 configuration. So let us try to find out the configuration. Okay, right. So how we can answer this question? So chromium 2 plus as reducing agent. Reducing, not agent, is reducing. But Mn3 plus is oxidizing. Oxidizing. Okay. Now, what is the electronic configuration of chromium? Cr. What is the atomic number? 24. And what about manganese? 25. So, which is the nearest electronic configuration of, inert gas configuration?
Xenon.
No.
Argon.
Argon. Argon how much? 18. So, chromium and this can be written as I mean, what about chromium 2 plus 22? Is it not? The electron number has come down, 22. What about manganese? Manganese 3 plus means how many electron? 22. Okay. So in that case, the nearest electronic configuration, I mean nearest inert gas configuration is krypton. Is it not? Not krypton, argon. And here argon 18. So you can subtract. Okay. So finally you are able to get 4. It means D4 configuration. D4 configuration. So this is a simple way to obtain. Otherwise you have to write down the electronic configuration completely and arrive at the D4 configuration. So our objective is to quickly arrive at this electronic configuration. Anyway, so it is already given, but we want to prove that. So both of them have D4. The question is why one is reducing, the other one is oxidizing. So here the problem arises because of splitting of d orbital. Take down. In the case of let us consider chromium first. Chromium, and what is its oxidation state? 2 plus. And what is the electronic configuration? 3d4, and 4 is a 0. Is it not? Now in this case, what is said? Chromium is reducing. What is that? Chromium is reducing. It acts as a reducing. Reducing means what? Reducing agent means it undergoes oxidation. Is it not? Reducing agent means it undergoes oxidation. So it undergoes oxidation and it is a reducing agent. Okay, so it becomes Cr, and what about this? Cr3 plus, am I right? With the release of 1 electron, correct? So what is the electronic configuration now? Tell me. 3d 3d 3 4s 0. Okay, now when we work out the electronic configuration, that is by the crystal field splitting, okay, it splits like this, as actually that is the d5, that is when you represent the d orbital, it should be represented as 5 boxes. Is it not? 1 2 3 4 5. So we used to write for this one, that is 3d4. Is it not? 1 2 3 4. Am I right? 3d4. And here there is no electron here because it is 4s0. But in this case it behaves like this. Okay, so this 1 electron has gone, so it becomes, it opts a splitting of d orbital like this, and thereby it achieves, okay, here unpaired electron, 3 unpaired electrons. And what do you call this orbital? This is energy. So it occupies the lower energy, the 3 sets. What do you call it? T2G. Are you able to recollect?
EG.
And what about this?
EG.
EG. Okay, so because of this splitting, okay, so you are able to get the chromium 3 plus is highly stable. Are you able to follow? Why? It is half filled, is it not? Because it is a half filled T2G orbital. Okay, half filled T2G. Okay, so that is why it easily undergoes oxidation. So removal of electron is feasible here. So it acts as a reducing agent and undergoes oxidation. Is it clear now? Can you write down the Manganese, try. So in the case of manganese, Mn 3 plus becomes, by adding electron, it becomes Mn plus 2 oxidation state. So what about the electronic configuration? 3d 4 4s0, and here by taking one electron it becomes 3d5. Okay, the same 4s0. Here no splitting, that is it attains 1 2 3 4 5 and 4s, and here 1 2 3 4 5 4s 0. So 1 2 3 4, so it becomes 1 2 3 4 5, so half filled. Okay, so here this is more stable. Similarly in this case, half filled by 2G, so it is more stable. So it opts for oxidation, is it not? Whereas this one prefers to undergo reduction. Okay, right? So you can write like this: chromium, but you have to represent this in as a very good statement. You please note down. You have to explain with the electronic configuration, but the statement is very, very important. Please take down. You have to write all these things, but write down the statement. Cr3 plus is highly stable due to the presence of half-filled T2G orbitals. Half-filled T2G orbitals. Whereas Mn plus 2 has a stable half-filled d subshell configuration. Subshell configuration. Mn3 plus prefers to undergo reduction. It means Mn3 plus acts as an oxidizing agent. Okay.